Hi everyone, welcome back to Observe and Resolve, your go-to series for troubleshooting and analyzing cloud-native technology. I'm Henrik Rexed, and today we are going to talk about how a single change can turn down your complete observability stack. Of course, we will explain how to avoid this after understanding the actual problem. So, quick question. How many of you have opened a Dynatrace dashboard that should have data, and instead you are staring at no data at all? The app is running fine, you got metrics, you got spans, you got logs flowing in Dynatrace, but your dashboard's dead. Raise your hand if you have this familiar situation. In fact, to be honest, I've been there more than one time. It's a complete normal problem. Here is the context that makes this hurt even more. Every signal on this dashboard comes from OpenTelemetry SDK. We manually instrumented, no one agent magic, no auto discovery. Our code owns every single attribute name, which means when something breaks, it's on us. Here is the ugly truth. Your observability is down. Somebody of your team has renamed a span attribute. Let's say customer.tier became customer tier. It's not a major change at all. All the tests were fine, passed, the CI went well, and the release went in production. That renaming silently disconnected your dashboards, your SLO, your alerts, everything. What if there were a better way of handling this? Something that caught the renaming before it was merged. The fix is one sentence. Your observability needs to be part of your application. Version it, tag it, and ship it with your application. So 5 pieces makes that work. Some of these could sound new to you, so let me give you one-liner explanation on each individual component. So the first, it's gonna be OpenTelemetry Weaver. It's a schema as code for OpenTelemetry. Your attributes lives in a YAML registry. Weaver validates them in CI. A rename get flagged. You can even imagine to use Weaver to score your instrumentation. Count the attributes of high cardinality. There is plenty of use case with Weaver. Second is dtctl. Dynatrace CLI, it's the kubectl for your tenant. Applying dashboard, SLO, guardians, everything as YAML. Yes, YAML. A simple DTL apply and your Dynatrace assets are completely updated. The third is a drift watcher, a GitOps action that drifts code against the Weaver registry and files up a GitOps issue in case of a drift. 4, Argo will reconcile the cluster from Git, so Argo Rollout will run canary releases controller to walk traffic 10, 50, 100%, and we're going to use analysis templates between each step to evaluate if our releases is fine. And 5 is the Site Guardians, evaluates your SLO for 10 minutes, returns passed, warning or fail. That's the verdict for Argo Rollout to wait. If it's fine, then we can continue the rollout. And last, if you have a drift change, we don't want manual change. This is where Claude Code comes in. We'll give it a couple of skills. dtcl native skills, the Dynatrace for AI for reading, and we'll be making beautiful dashboards. Observability agent skills for writing good OpenTelemetry instrumentation code and collective pipeline. Before we dive into the actual demo, here is your dtctl cheat sheet. 3 categories. There is auth, query, and resource management. The pattern is kubectl-like, so get, describe, apply, diff. Let's talk about the architecture. Here is the architecture, small cluster with 2 worker nodes, 8 gigs each, 4 operators running. Let me explain why we need each of those operators. So the first one will be the Dynatrace operator in Kubernetes monitoring mode. That means Smartscape sees the cluster topology, the pod, the nodes, the workload, but we are not running the code module. No auto instrumentation. This is 100% manual OpenTelemetry, which is exactly why Drift can be very useful to detect. Then we're going to use the OpenTelemetry operator that will manage the collector. So your app sends OTLP, the collector forward that to Dynatrace. And then we have Argo CDs for the GitOps approach. It watches our GitHub repo. When we make a new release, It will reconcile the cluster. Then we have Argo Rollouts that give us a canary deployments with analysis steps. That's how we hook the site reliability guardians into the release path. So 10% of canary, pose, ask the guardians, is it safe? If it's safe, we can move on to the next 50%, same thing, and then at the end, 100%. For the app, we're going to use OpenTelemetry demo, but in this example, we want to deploy the checkout upstream component. We'll replace it with a in-house checkout component built by Python. So we're going to replace the upstream one by a customized versions of the checkout service. Let's start with the first scenario, very simple one. What we want here is to add an extra attribute in our checkout spans, the cart size. That cart size will basically count the number of products that are in the cart. Very interesting KPI. We can also imagine to graph it in our dashboards. So what do we need to change to make this happen? There are actually 3 things that will be part of our commit files, or PR, depending on how we want to push this to GitHub. So the first one is on the code level. We need to modify the checkout code where we emit the span attributes. We're going to add the attributes. 2, we're going to change Weaver registry. So here we will declare the attribute, the type, the stability, and the meaning. 3, we have the dashboard. So here we're going to modify the dashboard related to our service. So we will add the extra tile here. So the query, and then we commit everything. We push it. So let's have a look at our CI. There's a couple of things that we go. First, we of course do the test on our applications. Then we look at Weaver registry to validate that every attribute has a type, a stability, a level, a descriptions. And then Weaver look at the difference between against the main blocks breaking changes, like type change if there's any attributes that has been removed. And last, we have dtctl that validates and parse every dashboard, every SLO to catch any syntax errors. Let's tag a new version. So let's say the version 1.1.0 and push it. So we will watch the release workflow. So we have 4 steps. Step 1, build and push the container image. Step 2, we run dtctl apply on dashboards, workflow, and the guardians. Every resources here lives in the repo. Step 3, bump the Helm values into image tag version 1.1.0. Argo is pulling the repo, sees the value change, it marks the app as out of sync, and it will try to reconcile and synchronize the changes in our actual cluster. And last piece is Argo Rollout walks to canary release. So here is what gets interesting. Checkout isn't a regular deployment. It's a rollout canary strategy. So first, 10% of canary pods will be rolled out. 90% will be with the other versions. If it runs, the analysis runs. If it passes, it will promote the canary release to 50%. He will pause. And then if the analysis run is positive, then he fully roll out to 100%. And if it fails, it rollbacks. So what is the analysis run doing? Well, it is running a Kubernetes job that calls dtctl get guardian run. So at the end, there's a guardian rel running. It will parse the actual verdict. Pass means promote, fails means abort. That's the hook between Argo and the site reliability guardian. Now, if we look at the dashboard, we can see that the checkout place order counts is also there as a new tile. So now we have one dashboard with the update tiles delivered by our GitHub workflow. Second scenario is this is something that could happen to everyone. Someone is doing some audit code and they see customer.tier. And I think we don't want to have dot, we want to standardize. So we're going to basically change this. So they rename customer.tier to customer tier. So here is how we can avoid or at least resolve it very quickly. The observability watcher fired GitHub action. It does one thing. Diffs every span attributes in the code against Weaver registry baseline. The issue body is structured with different information. So which attribute drifted, what was renamed, which dashboard query it, which SLO depends on it, everything that is required to let an agent to fix those changes. So here is how we're going to resolve it. We take the ticket URL or we pull out the tickets from GitHub using the CLI, pass it to Claude Code with 3 skills loaded. The observability agent skills pack teach Claude how to write perfect OpenTelemetry instrumentation respecting the semantic conventions. The Dynatrace for your AI gives the vocabulary to read DQL and build relevant dashboards. And then we have also the dtctl skills to build right DTL interactions. The agent reads the code, grab every places where this attribute is referenced, and then read the registry and the dashboards. Then it produces 3 file diff. Let's walk through what makes this output correct. Look like this code. This is not like a basic change where you replace back the old attribute. It emits both old one and new one. So spans now will have both attributes. Why? Because dashboards in the wild are still querying customer.tier, and we only emit customer tier for the new versions. So the dashboard may be broken if we move on. By emitting both for 1 release or 2 releases, we give ourselves time to migrate every query to make sure that the dashboards will be loaded in the future. The DQL query now use coalesce. Try the new first. If it's null, fall back to the old naming conventions. This works during the overlap window when some spans emit both, some emit only the old names, or eventually all emits only the new names. So what did we cover so far in this episode? Lots of things. So we looked at semantic conventions, dashboards, SLO, and release gates, all YAML and versions into our Git repository. Weaver catch breaking changes in our commits or PR. Claude can resolve the issues on our SLO and dashboards, and we have a guardians that blocks releases before the actual being rolled out. And everything depends on dtctl. dtctl is used in our GitOps actions and in our Argo, making the bridge between the code change, canary releases, and Dynatrace configuration. Everything you saw today is in the GitOps repository, so the link is in the description below. So clone it, run the 3 scenarios, look at the different how it's been implemented, if it gives you an idea, perfect, let me know in the comments if it's useful. And if you want to try dtctl and you never tried it, very simple, you need a dtctl auth login, and then you can get your dashboards, apply things. And more than just using dtctl, don't forget to get the dtctl skills to your agents and the Dynatrace skills to your agents, so then they can build your dashboard, your SLO, know how to query using DQL, and then you will simplify your actual workflow to configure Dynatrace. So we cover lots of concepts today. So let me know in the comment which of the solutions you think is useful for your release management. I will be very eager to learn about your experience. If you enjoyed today's content, don't forget to like and subscribe to the channel. So thank you for watching and see you soon for another episode. Bye.